G'day, it's Clive Rocksinger here. I've been designing this transmission. This is a model. There's no teeth yet. And I've really found some extremely interesting things about... I found some interesting stuff about transmissions, and it's not as complicated as I thought. And again, I was lied to when I was at school. Now I asked the teacher, I can't even remember how long ago, well I was probably a kid at school, and they were talking about transmissions, and I said, how do you get the spinning gear that's doing like a zillion mile an hour, how do you mesh that with another gear when it's doing about 3,000 RPM? I didn't ask anything that technical at the time, but that was pretty well a question. They said, that's why it's so hard to design transmissions. That was a lot of crap. Gearboxes don't work like that at all. At all. Gearboxes are as simple as hell. How it works is this. See this gear here? That one there is not connected to the shaft. Right? And what you have is I haven't got the picture of the they call it a dog, which I call them grabber gears because I think that's a condescending term to use myself. Seriously, it is. It's using the term dog in any reference. I think these days it can be adapted in so many ways that you really don't want to have that term, and they really need to sort of take that out of engineering and change them to grabber gears or something like that. So I call them grabber gears, but it's actually a dog. It's a gear dog. And what happens is these gears are in mesh all the time. This is the easiest way to do it. And when they design transmissions, these software programs that they give you to design this stuff, I don't think they allow you to do things that would make it a lot easier to make the thing work. I think they overcomplicate everything. So how it actually works is all you have to do here is, the reason there's 4 gears is you can change because you've got a limited amount of space, you can change the ratio of 2 gears, but this actually changes the whole range of gears. So if you want to change a range of gears, you change these 2. And then it makes it a lot easier to design these ones, especially when you've got 3 or 4 gears you're trying to change. So what you do is, this is a sort of a secondary balancing set of ratios. So you work out all the gear design ratios that you want, and then you use these to sort of set the base of it. Now this is a 1-speed gearbox. Now how it works in actual fact is that's free spinning, and when you want to engage first gear, it's a 1-speed gearbox, all you do is you slide your dog forward, and it connects the gear, which is that one there, which is free spinning, it connects it to the shaft. It's sliding on a spline. That's what the splines are for. And if you look at this here, this is how a gearbox works here. See the dog here? See that there? All that does is grab onto there. That's got nothing to do with the damn gear at all. These teeth are in contact all the time. All you do is you've got to engage the dog. There it is. That's how you change gears there. You just slide that forward. And what it does is it connects it to the shaft. Disconnect, connect, disconnect, disconnect. That's all it is. So all it's actually grabbing are these things that are sticking out. So the gears are in mesh all the time. So gearboxes aren't anywhere near as complicated as they look. They're actually quite simple. And my personal opinion is what you could do is see that how they're straight. I reckon I'd be inclined to put I was going to say put a taper on it, but I'm just wondering, that doesn't actually look like it'll work. But anyway, this isn't really all that complicated. So in actual fact, you don't really actually mesh gears together. And they said they used to have dog boxes and they used to crunch the gears together, and that's probably because I was trying to do this. And then they realised if they used dogs, they didn't have to do that. You just leave the gear in mesh all the time and just connect your dogs. So that's all that's got to happen. But I think you have to have it happen on both sides. So you have to engage the dog on this side, and I'm not really sure whether you have to engage the one on the other side as well in some cases. because you've got multiple gears, and I think that's why it does come a little bit complicated where you've got to engage dogs on both sides simultaneously. But yeah, I've got this gearbox being designed, and I'm making the journals up at the moment, and then I take it to stage 2 and start working out all the gear faces and stuff like that. I'm already designing gears, and I'm going to design a 1-speed gearbox to start with and do everything I can to it. I'll put fluid and everything into it, weigh it, and calculate all. I'll use mensuration and calculate all the weights and stuff like that, and it'll have to go in stages, and work my way up to design the Terran Fireblade transmission. But yeah, I was quite surprised. Another thing with gears, what makes it very, very hard is they're all facing one another, so the tolerances have to be unreal, and I found that you've got to change the tolerances with respect to how big the gear is. So tolerances for screws, I was using 0.5 millimetre. I've had to go right down to less than 1/4 millimetre tolerance on these gears because they're flopping all over the place. The bigger the gear, the tighter the tolerance, because it tends to get a bit of tilt on it. So yeah, and on a real transmission, you would you'd have to design the CNC lathe where it'd be 1/10 of a thou tolerance. It'd be super tight on a real transmission. You couldn't have any play at all because it'd rattle like hell. So yeah, transmissions are hard to design, and they're very, very hard to machine up too. You've got to have them dead on because they're facing one another, the gears. Anyway, yeah, it's all going alright. This is the way I've been designing it. I drew it all the scale and I blew it up, and I just take the dimensions off that, and that's working really, really good. See how I write the dimensions down there? And let's go into Blender and dimension them all up. But one thing with Blender, it's a bit tricky. You see how it hides the numbers? And I'm finding that's causing me a few problems, because it reads 17.2 and it's actually 17.245, so you got to watch that with Blender. But yeah, that's my little model transition to 1-speed. So Clive Rocksinger over and out.